Hello everyone, welcome again to our next video. We're doing lessons 522, how do arithmetic sequences work. Now we just started talking about sequences today, and I know it's a little bit tricky, so we're going to start breaking it down part at a time. Right now we're focusing on arithmetic sequences, okay? Lesson 521, you learned how to identify arithmetic and geometric sequences. Today you will solve problems involving arithmetic sequences. Use the questions below to help your team stay focused and start mathematical conversations. What type of sequence is this? Hint, hint, arithmetic sequences. How do we know? How do we find the equation? And is there another way to see it? Now, just a quick review. An arithmetic sequence is when you do what in a sequence? It is when you add a constant amount. Geometric sequences are when you multiply by a set amount, okay? So it's really, really important to keep track of that difference there. Arithmetic sequences, you are adding a constant amount every time. Geometric sequences, you are multiplying a constant by a constant number every time, okay? Please make sure you are comfortable with that. All right, we are gonna do one problem together as a class today, okay? One problem together, and then tomorrow we'll do all the rest of this, okay? 556, learning the language of sequences. By the way, you will need graph paper for one of the problems here. If you want to do all the work on graph paper, that's fine. Or if you want to do it on line paper and then just make a graph on graph paper and tape it on here, that's fine. But on the homework, on the notes, I'm expecting to see some graph paper. So please make sure you do it, okay? Learning the language of sequences. Sequences have their own notation and special words and phrases that help you describe them, such as term and term number. The questions below will help you learn more of this vocabulary and notation. And again, notation is just another way to say, way of writing it, okay? All right, consider the sequence, and actually please write this down. For problem 556, write 556 and write the sequence. -9, -5, -1, 3, 7, ... okay? Write that down at the top, nice and big, okay? -9, -5, -1, 3, and 7. First of all, when we're going to be doing a lot of these questions, just in a quick pause and answer, and then unpause to check your work, okay? Is the sequence arithmetic, geometric, or neither? How can you tell? So pause it, answer that question, and then unpause when you're ready. If you analyze it carefully, it is an arithmetic sequence because you are adding, I'm going to run out of room, a constant amount. Now, please tell me you wrote some type of complete sentence there, okay? It is an arithmetic sequence because you are adding a constant amount. What is the first term of the sequence? Here, it's fine if you just say the first term. And it's really, really important that you understand and feel comfortable with what the first term is. The first term is -9. Okay? It is always the first shown value is the first term. And I know you're like, that sounds really stupid, Mr. Ramirez. It sounds really obvious. It is, and yet it can confuse people. So please make sure the first term in the sequence is always the first one shown here, okay? So okay. When the sequence generator adds a number to each term, the value that is added is known as the common difference. Difference don't we find that different? What does difference mean? It's the answer to a subtraction problem. So we find the difference by subtracting these quantities. So like 7 minus 3, and 3 minus -1, and -1 minus -5, okay? What is the difference between each term and the term before it? The difference between each term and the term before it. What is the sequence generator? The sequence generator in this term, sequence generator, what is it? Is 4. Sequence generator is 4, okay? You could also say we're adding 4. Because sometimes we're going to be subtracting numbers, okay? Okay, so again, hopefully everything feels pretty comfortable now, okay? D, record the sequence in a table. Remember, a sequence table compares a term number, and here's an important, you might want to write this down again. Term number is your n. N is term number. The value of each term is T of n, okay? Write it down. So on my table, we're going to have n and T of n, okay? N is a term number. So we have term number 1, and 2, and 3, and 4, and 5, okay? Yes, we always start tables for terms, for sequences, with term number 1, because that's the first value in the sequence here, okay? So the table seems pretty obvious, but there's some tiny details that you really need to pay attention to in the difference between them. So here would be -9, -5, -1, 3, and 7. Cool? So this is a term number, and the first term, the value of the first term is -9. The value of the third term is -1, okay? So when I say, what's the fifth term, you tell me 7, all right? Now, question E, here's where it starts getting a little trickier. It says, what is T of n? Now, T of n is the value of the term when n equals 0. By the way, this T of n is very similar to f of x, isn't it? Okay, so we're looking for what number right here. This is referring to the value of what number when n is replaced into there. So T of 0 is not on here, is it? It's a value that would come before then, okay? Before this 1, so it would come like over here. Well, if I follow that, T of 0 would be what then? T of 0 would be -13. So term 0 would be -13. Now, do we have a term 0? Yes and no. Term 0 does exist, but we don't ever put it into my sequence. Because if I go like here and say, oh, term 0 is -13, well, guess what? Once you've plugged it into your sequence, that is now term 1. Do you see the difference there? I know it's really tricky, but there's a big difference, and it really makes a difference there, okay? So term 0 does exist, but we never write it in there, okay? All right, next part. Oh, my calibration's a tiny bit off, and so it's throwing everything off. Okay, we're now going to graph the sequence, okay? So at this point, you're going to pause the video, you're going to graph it, and then come back and check it. And by the way, should it be continuous or discrete? Now, before you answer that, I'm not going to answer that right now, okay? So at this moment, graph it, maybe leave it discrete, think about it as you're graphing it, and then think of that conversation and discern, should it be continuous or should it be discrete? When you've got your graph done, please unpause it and then come back and check with me, okay? All right, go. All right, sorry, I gotta peek back here. I want to make sure I do my sequence okay. So here we go. Here's 1. Man, my calibration. I gotta pause a second here. Sorry about this, everyone. You're gonna be a little weird, like I see calibrating in the middle, but for the graph, it really matters that the calibration is perfect. 2, 3, 4, 5, 6, 7, 8. Okay, so 4, 6. And then my terms, I think I can go down 4, 6, 8. So -8, 2, 4, 6, 8, +8. And then I plot my points, okay? So I've got -1 is -9. So 1, -9, okay? And then it's grown by 4 every time, right? So okay, I think those are all the values I can fit in my graph, okay? I've got that information right there. So I've got those 5 values. Should it be discrete or should it be continuous, and why? Well, here's the thing. It should definitely be, by the way, remember, continuous has nothing to do with whether it continues on forever. Continuous means it continues between points. Can I find a term halfway through? Can I find term number 1.5? Can I do it? No. Term numbers are always going to be specific values. If I start plugging numbers in, if I go back to my sequence and this sequence over here and start plugging numbers in between, like -3, -7, then this is term number 1, this is term number 2, this is term number 3. So it always goes, the numbers listed are in order of the term numbers, and so I can't plug anything in between. Therefore, this should be a discrete graph. Discrete. Because I cannot have values in between my term numbers. Now here's a challenge. Write an equation beginning with t of n for the nth term in the sequence. In other words, that means write an equation that can help me find any term in the sequence. And yes, you're going to start with t of n. So what is the equation for this problem? Well, think back to your work over here. Think to your graph. As you notice, this does seem to be linear. So it should follow the y equals mx plus b format. All right? So if I follow the y equals mx plus b format, I need to find my slope, and I need to find my y-intercept. What's my y-intercept? The y-intercept is term 0, isn't it? Which is not on here, but I do know is -13. And what's the slope? So it should be t4n minus 13. Okay? Now, so I still use the y-intercept concept right here to find the y-intercept, and then I use the slope right there to see the growth of what's going on there. What is the domain of the sequence equation that you have written? What domain, what values could n be? What could n be? Okay, so I guess the question comes down to, could it be decimals? Could it be negative? Can it be 0? Can it be all values? Well, the domain, what is it? Pause. Write it down and see if you're right then. When you got it, unpause it and let's see if you're correct. Alrighty, here we go. The domain is all integers greater than or equal to 1. All integers greater than or equal to 1. All integers, by the way, are positive and negative whole numbers. So all integers that are greater than or equal to 1. So 1, 2, 3, 4, 5, 6, 7. All whole numbers from there on out. Okay? All integers. It cannot be decimals. It cannot be negative. It cannot be 0. Okay? Because if you put term 0, then that makes that the first term. It just doesn't work. Okay? So term 1 is always the first value in the sequence. And one last question. How is the common difference related to the graph and to the equation? How does this make sense? Why does this make sense? Well, I kind of already answered this, okay? The common difference in this case is adding 4. That's a common difference, is this 4. It is the slope of the sequence or the graph. Okay, it is the growth quantity. It is how much it's growing by every time. And it makes sense because you're adding 4 every time. Therefore, that would be where my slope is that way. All right. Well, that is it for today, ladies and gentlemen. So thank you for taking notes on this. Make sure that you save these notes for tomorrow. We will continue this lesson tomorrow. Have a good day, and I will see you tomorrow.